Okay.
Rolling.
So welcome and bienvenue to another Hack Night, NeurotechX Hack Night.
Morgan, you muted yourself.
I think it was an invitation for someone else to do the intro.
Yep, that would be cool too. How did I do that? Sorry. Let me do I need to go back?
Yeah.
was I muted the entire time?
Yeah.
I had no idea what you were going to say next.
Yeah. Yeah.
Okay. All right. Sorry. So, take two. Welcome and bienvenue to another NeurotechX Hack Night. NeurotechX is an international community that facilitates the advancement of neurotechnology. Our pillars are community, education, and innovation. We have chapters worldwide, lots of meetup events, although mostly online, and a very active community on Slack, over 4,800 members. So if there's not a chapter in your community, please let us know and we can help you start one. There's also a lot of student clubs that if you also don't have a student club at your university, also let us know. Certainly join us on Slack to keep the conversation going, and let me know if you need a link for an invite, and also check out learn.neurotechx.edu and for our online platform of educational material, and also sign up for our newsletter and check out the job boards if you are interested in a job. All right. So thank you. Sorry for muting myself. And yeah, welcome to another Hack Night and a very full week. I don't know what if there's usually at this time we also ask anybody who's new to introduce yourself and tell us what brings you here. There is no requirement, though. You can also tell us later. So certainly a lot of, like you see in the meetup agenda, there's a lot of conferences going on this week. ISMRM is the big MRI conference. But as I said in the meeting notes, I saw that like Brain Products and some other groups were, of course, rolling out like EEG and the magnet products, or at least talking about their particular EEG and the magnet products. It's also the conference where there will be some discussion of doing other weird things in a magnet, like putting in TMS coils and hopefully more of injecting current. So yeah. So I don't know if anybody's caught any of that. It's not always there, but what you want to look for to search on is like something like MR-EIT, and maybe sometimes called neuronal current imaging, but it's been a while since they've called it that. Of course, there's the Allen Institute modeling workshop that is ongoing, and there's a good link, and you can still register for it. There was, Stephanie Jones. For people who aren't familiar, this is the PI for the human neocortical. I forget what the last N is. Well, I want to say solver, but it's HN.
Neurosolver.
Neurosolver. Okay.
A neologism, I think.
Yeah. So hnn.brown.edu. So she was talking, and who's the other? I mean, they're all great speakers. Some are doing much more like EM, 2-photon imaging, things like that. And but Clay Reed had some interesting connectomics. It was another interesting talk today. And yeah, happy to take us back to the conversation of that we were. Well, anybody else got news or updates, or is there anything you're tracking this week that might be interesting to share?
I saw a tweet saying that you could do boilerplate Numpy in Tensorflow.
You could do what?
Which is new to me. Not that you do boilerplate Numpy.
Oh,
in Tensorflow.
Gotcha.
In my back time.
I'm
not a TensorFlow expert, so I don't know if that's like.
Is there a new
exciting.
TensorFlow?
I don't think this was a major release.
Okay.
This was kind of extra feature. You'd think it would be a big feature, but.
Yeah. Yeah, I'm not sure either. The only package I know that uses TensorFlow is Pyrates. That one from Leipzig. But that's only if you're doing big networks, and certainly all their tutorial stuff you can just use Python. Oh.
I thought it'd be an interesting question. Again, I don't actually use these tools much, but whether people would gravitate from PyTorch to TensorFlow if you could be more Pythonic in TensorFlow, because that's that I do understand is that at least the TensorFlow API that I was playing around with a year or two ago was really clunky and like not natural to write things in compared to PyTorch.
Yeah, the way that I would describe it is you can write neural networks in TensorFlow natively if you love thinking in vectors or you need really high performance. Both of those are kind of unnatural to me. So Keras, the Python framework, middleware, whatever, can use TensorFlow as a backend for the processing, but you write your code in Python and in Keras, and it's much, much easier to use. So there are distributions of Keras that include TensorFlow or grab it for you. I think the Conda package does that or whatever. And the only tricky part is getting TensorFlow GPU. If you need that package, that's not what they install. They install TensorFlow CPU. So if you just want to experiment or whatever, you can just install TensorFlow Keras with the TensorFlow backend, and you're good to go. You can just write your code in Python, and then you can use pandas really easily to manage the data frames. The Numpy enhancement is sort of like, well, if you don't want to use pandas data frames and you just want to feed Numpy arrays, now they support that. But again, that's more of like a little bit of a low level thing. So if you're comfortable with pandas, that works really well today. Like you can load your Numpy array into a pandas data frame and then feed it into Keras really easily. So I would just suggest, like, if Python is comfortable, Keras with the TensorFlow backend, which I think is how they distribute it, is a great sort of in-between step.
So Keras is actually now included in TensorFlow. It's officially their front end, like their main API.
Oh, that's great. That's
yeah,
great.
Ever since I think that was it late last year or late? I think it was the year before that, late 2018, that they made the TensorFlow 2.0. I think it is with the Keras main API.
Another thing you could look into that also uses Python for machine learning is Rapids.ai from NVIDIA. It's, if I remember correctly, it has a couple similar features to Pandas, but I don't know how well suited it's been developed for the types of machine learning models you currently need. Like, there's a lot of people developing with it now, but it's still pretty early in its release cycle, so it's not all that stable. But it's pretty easy to use and it's very fast, but it also likes big data sets, like hundreds of thousands of like data points.
I just dropped something in the chat that somebody shared through the NeurotechX Facebook, and it's like the atlas of the brain, and there's like an article, but I just shared the exact link. It's called the Jülich Brain Atlas.
Yeah, Jülich.
Jülich?
Yeah.
Oh my goodness. And it's like an interactive MRI scan. You could just drag your mouse and look at the entire cross section of the brain and highlight whole sections.
Yeah.
And
it's a lot more than that.
They don't really know what they're looking at, but they're learning.
Resolution.
Do what?
It's like a really, really awesome MRI. Right?
Yeah,
because it's from light microscopy.
And who's gonna get? I mean, we can't. Who can afford the software to drag your mouse and look at these cross sections? And they've just got the data, and all you have to do is load it in a web page and move your mouse around. This is cool.
Yeah, yeah. No, it's awesome. Yeah, this was. I mean, I saw science, but I don't know if it's like science or science reports or, but yeah, there's a paper associated with this release that was just a couple of weeks ago, right, John? Yeah, but
what I didn't quite get is this what Big Brain is now called? Because previously this was thought there was.
Yeah.
I don't know if, or is Big Brain something different now?
Well, certainly like the active Big Brain seems to be Highball now. That's
Highball.
But yeah, I'd want to pull up. Let me just see. I mean, for a long time, Jülich was still using their own reference standards, like standard brain. It was.
Sure. So can I just sort of address Rashik's question real quick?
Sorry. Yeah. Go. But just we do need to give people a little bit of setup in terms of what Rashik has, and so this is speech EEG, where speech is being presented to one of the ears. And yeah, chime in and tell me if I'm getting this wrong. But and then you've got 1 minute of data for each presentation. And so this is only two minutes of EEG, and I believe this is with Muse, so we're talking about 4-channel EEG.
Yeah, so Rashik, you'd like to be able to see if a neural network can distinguish what someone is listening to. And in this case, you have two different audio sources, and you'd like to see if you can get the network to sort of like correctly guess which thing that they're listening to from like a 1 minute sample of data.
Yeah.
Yeah, so what I would say is, in experimenting with various deep learning networks and what they can do, one of the things that I found is that some tasks are very, very easy for a neural network, and some tasks are very, very difficult. And that sounds kind of like generic, but very quickly you'll see if a neural network can train on what you're giving it, or if what it's getting is sort of like not something that it can learn from or generalize or whatever. So is this two different like audio speech recordings? Like one is a certain kind of speech, or is it like music versus speech? What are the two sources that you're comparing?
So there are like two different automated phone call recordings. So one of them is about, there are different topics. One is about a hotel reservation, and I think another is about an airline something.
Mm-hmm.
Yeah.
Right. So the things that you don't know ahead of time are, is the speech patterns in these calls unique and different enough that something about how the EEG signal is going to be generated is going to like give the network something to distinguish, right? So there's a couple of things you're not sure about. Are the electrodes in a place that's going to be useful? In other words, do they pick up some distinguishing characteristic of listening to the speech? And then the second part is, are the two things that you're trying to compare somehow different enough that in the signal it's going to be noticeable? So I think you can start with something like just a few repeated samples of the same data. You know, like if you listen to the same thing 3 or 4 times, record yourself each time, you can just do some basic checking. But if you find that that's not training at all, you might find that using a completely dissimilar source for comparison, like an example of someone listening to a phone call, a recording in this case, and then the other one listening to some like classical music. You might find that those are different enough that the network can distinguish them, even though. So like what I would suggest is grab a couple of different sources. You can do them in 1 minute slices. And then just pick some package. The other thing is, it doesn't take a ton of data in all cases. There are many applications where neural networks need an absolute ton of data, like GPT-2 to generate, you know, natural speech needed terabytes of data. Absolutely. Like some tasks require like a big data approach, but there are other tasks that neural networks just really, really seem to do well at. And, you know, you don't know ahead of time before you try whether this is going to be something that's going to be really tough for the network or actually relatively easy. So yeah, I would suggest something like start with, you know, 5 to 10, however many you can tolerate personally, repeated recordings of, you know, something like listening to music or listening to the 2 recordings or whatever. And then the other thing with the Muse is each channel is kind of its own source. So there are 2 major approaches that you can use with neural networks. You can either pick one channel that you're going to use as your sort of like comparison point. And that's very easy. You just load that time series into, you know, the network, a simple convolutional network, and that's it. But a more fancy approach, and this doesn't necessarily mean that it's going to work better, it's just a different way to do it, is you can actually feed all 4 channels in. And, you know, this requires a little more, you know, structure to the network or whatever, but you can have a network that consumes all 4 EEG channels simultaneously and makes its decisions on that. But you see, this is where this sort of dark arts of neural network comes in. You don't know, is 1 electrode going to be better than 4? In some cases, a network is much better with 1 if you're picking the most useful one. But then in other cases, you know, having 4 for comparison works better. So there's just a lot of iteration and playing with it. And yeah, I would just suggest start with a few samples, try like an architecture or 2, and ultimately what you're looking at is, does this network train, or is the parameters that I'm giving it sort of difficult for it to work with?
Wouldn't using multiple channels be similar to the way we handle, say, in an image where the 3 channels are the RGB values. Won't it be similar to that?
Yes, and then a lot of times people will take an image and make it grayscale because it's a lot simpler than doing that. So it's interesting because what you're really guessing is this relevant information for the network or not? If it isn't, then I don't need to include it. I don't need to go through the trouble of giving it all 4 channels. You know, you can just pick like maybe the TP9 or the TP10 electrode, whichever one is closest to the ear that you're listening to, might be a good start point. They tend to get good signal and they're kind of close to the ear. But you might find that the frontal electrodes give you a better, you know, signal, or there's something about the frontal processing that makes it easier for the network to distinguish. So yeah, you can try both approaches. You can either include all 4 channels, and yeah, that would be more like the RGB type thing that visual networks use, or you can just, like I said, for experimentation, pick one electrode, feed it into a network, and just see, do you get accuracy above random?
One question I was wondering about is how are you getting rid of other possible things that could cause noise, whether it's from your visual system, like are your eyes closed, or are you looking at like a nondescript blank wall, or situations where like you could accidentally be hearing other things? Like, how noise isolated are you when listening to these audio recordings? And also, what type of voice is the person in the audio recording speaking in? Because different types of voices are much easier to pick up cognitively for certain people. Like, I know my voice is actually very easy for people with cochlear implants to identify and distinguish compared to a lot of voices, and they aren't fully sure why, but they think it has something to do with my voice has a level that implants can turn into a signal that brain really likes. Yeah, sorry, I'll be quiet. Like,
right now I'm just using a filter to, I think, I need to look at the range actually, I forgot. So yeah, I'm using a bandpass filter from 2 to 8 hertz.
Just dropped in the paper that I had sent Rashik earlier, just a recent bioRxiv paper that's looking at auditory attention detection. For anybody who's interested.
Yeah, in terms of the filter, Rashik, I would suggest leaving all the way up to 50 hertz when you initially experiment, and then you can always like 2 to 50 is probably a good range, because a lot of 2 hertz to 50 hertz if you're gonna filter. I would say after about 50 hertz, the muse is sort of going to fall off in efficacy, and you're getting closer to like the 60 hertz line noise and so on. But there are times where gamma will give you a little bit of something or whatever. So I would start with that. And then the biggest thing that usually comes up in EEG is blink artifacts. And so eyes closed may help. But on the other hand, if it's uncomfortable for you to record, really you can kind of get away with either. If the noise is present in all the signals, the network can usually learn to just ignore it. So it's kind of like, controlling helps, but at the same time, if you're just trying to get a rough comparison, sometimes you can just give it a shot.
Yeah, right now, I want to compare the deep neural network approach with the current approach I have. So I'll probably keep the pre-processing steps the same for now, at least.
Sure, sure.
And then maybe change it. So just to see if it actually works better or worse.
That's great. Yeah. So I would suggest starting with like a simple convolutional network and just see how that goes. There are some pre-built in models in whatever package you use, but Keras has some. So I would just say, yeah, grab a few, like I said, 4 or 5 I would use as the absolute minimum, and then see if it trains. That's really kind of like the way that I would start experimenting with it.
Mm-hmm. Yeah.
And super glad that you came with questions. And again, I don't know if it's possible to share the data you have, but it always helps to if you can, if people can see what you're dealing with.
I probably can. There's a data channel, right, where we share it, or in the Slack.
Oh yeah. You know, if you can put it on like Google Drive or something like that.
Okay. Sure.
And you've got the audio stream, the speech stream recording.
Yeah,
too.
I have that too.
Yeah.
I just make your recordings probably aren't huge, so in the interest of getting feedback, easy feedback from people, I would just make a temporary GitHub repo and stick it on there with the code to load it in and do the things you want to do, and then kindly ask some people to kind of weigh in and check it out with the, a kind of use it ready to go environment that you've set up directly from the GitHub repo.
Mm-hmm.
Yeah. What format is the data saved in?
So I think it's a WAV file. The sounds are in the WAV file, and the others are, I saved the EEG in the Numpy array. Oh,
okay, a MATLAB. Okay, cool. So just a .mat file. Yeah.
Yeah.
Okay. Yeah. Then if there's, like John said, like having a little loader function, if there's anything people need to know about that MATLAB structure or something, would be super helpful. So I just want to again say, if there anybody who's new, first time here, if you would like to introduce yourself and just tell us a little bit about what brings you here, now's not a bad time.
Hi, am I audible?
Yeah, hi.
Hi, I'm Divesh. I'm from India. I study electronics and instrumentation at BITS Pilani University over here. And I'm extremely interested in neuroscience and neurotech. And I work through my Cohen's neural signal processing course.
Yeah.
And I'm just continuing exploring everything. And I'm currently trying to work with Morgan over here for processing the ERP core.
Yeah.
And I'm also working on a few projects at my college as related to brain-computer interfacing.
Gotcha. Not the EEG part. Other parts of BCI.
So the topic for the college project, I haven't exactly decided yet.
Okay.
So I'm still working on that.
Cool. No, that's great. So yeah, you've been helping me in terms of just getting out those tools that I think people should look at if they're not using MATLAB. So ERP core is available. You can download all 40 subjects of pretty much raw data, but they've got it all set up in .set files, which is EEG Labs format. And yeah, so the cool thing being that if you create a Conda environment and you Conda install M&E Lab, you can also view these. And of course, this is, you know, to Alex's point about, you know, blinks being kind of like certainly one of the biggest things that you got to deal with. M&E Lab, like EEG Lab, is really used for doing that ICA artifact correction. And anyway, we'll hopefully talk about that some more. So it's 6:45 here on the West Coast. I was going to turn it over to John really briefly, just to see. Well, you've got big news because the GitHub repo has been significantly upgraded.
Yeah, I guess you can call that big news. I'm just slightly trying to tone it down a little bit because we have some gaps in the documentation still. But the well, yes, you're responsible for some of that, but I'm responsible for some of it as well.
I'm working on it.
But you know, that's not necessarily a reason to not trumpet the fact that EEG Notebooks is in version 0.2.
Yeah,
officially, whatever that means. I decided that the previous version was version 0.1. Yeah. And you can still find, so just an important note to people, and this is actually important for users. I move things around. So I'll just tell you some, well, if you want the old stuff, then it's still there in its entirety in a different repo, which I'll just pull up and put in the chat.
Yeah.
Which I basically literally what I did is I renamed the original repo to _v0.1, and that has all of the Git history from, you know, 4 years of the development of this project, or whatever, and a lot of stuff that we've removed. So the download size for the old repo is about 800 megabytes, and the new repo is a slim and tidy 30 megabytes.
Yeah.
And the reason for that is basically the data and the Git history, you know, both of which aren't things that you really need in a repository, which is why I took them out. So so on those 2 points, okay, so this is the link. This is the old one. If you used EEG Notebooks for the last 2 years, 4 years, whatever, and you're horrified by the improvements that we have introduced, and you want to see things the way they were, but I strongly encourage you to not do that and to move with the times.
Yeah.
And the times are moving to the new version of the code, which is in the original repo name. So I renamed the old repo and then created a new repo that has the same name as what the old repo was. And people who kind of know how Git works will know that that doesn't automatically reroute you to the new one. So if you have like a clone of the original one, yeah, and you start pulling stuff, then it's not going to like magically become the new one, even if, actually, to be honest, I think a lot of messy stuff could happen with those URLs.
Speaking of messy stuff happening with those URLs, John, I can't push anything to the master repo anymore because I'm not.
Oh, right. Yeah. No, thank you. Thank you for that. That is easily fixed. That is not a problem at all.
No,
but okay.
It's awesome. It's awesome, right? Because this is the big refactor come to life.
This is the branch that was called the big refactor that has now grown up and grown off the branch called the big refactor and is now on master.
Sure.
So for development people, and really, I want to emphasize this as well, right? So that many of the people on this call are kind of users and user developers, and kind of interconnected with communities that are developer and use developer communities. Please check out the new stuff and do new things. And your changes are going to be pull like branches and pull requests to master. So we had this awkward thing for a while we were working on the refactor, which was that it was a branch that wasn't the master branch, and it's kind of a bit complicated to get people to do to work on that as the main version of the code. But we're kind of past that now. So the main version of code is the master. So you don't need to worry about all this dev crap and like what things I've been telling people, which was like, actually all the new stuff isn't on the master branch. Don't use the master branch. Right. We're past all that now. So all the stuff is on the master branch, just like a normal repo.
Yeah.
And there are API changes. I've put this on the call a few times before, but I'll just put it one more time, just in the chat. So the documentation page, which is linked to from the README, and is hosted on GH Pages and is built with Sphinx Gallery, which I've learned a lot about over the last few weeks, is there. So that's kind of the place to look for descriptions of the API and stuff. A few cool things to comment on what's new. One is, well, things are modularized a lot more. So we don't have like these notebooks that are like one notebook that does everything beginning to end. We've tried to break it up so that, you often just want to record. You don't want to analyze, right? So we've really split up a little bit the data acquisition versus the data analysis part. And so that's just useful from the point of view of data acquisition and running experiments. It means you don't have all this kind of extra stuff that isn't relevant to you when you're making recordings. But it also means that you can just come in at the analysis level and not worry about the acquisition part. And the acquisition part is often where there are kind of technical, hardware variants and so on that narrow down the user base and introduce kind of potential bugs and so on. So you can kind of skip all of that if you either don't have a headset lying around or don't want to worry about recording, and is a little bit more natural now to just look at the data and just look at the analysis parts. And for example, in the examples gallery, which I'll find another link just to point to. Sphinx galleries are kind of cool. Or at least I find them cool enough to spend some time figuring out how to make a website that uses them. But there's a little gallery at the bottom of this page, and the full gallery with all of the examples is here. So essentially, this is another design thing, that the source code for all of these examples, so mostly the analysis actually, but not so much the recording part, because the recording, that's not the right way around to say this. The source code, as the way that Sphinx Gallery, the Sphinx Gallery kind of model works, is you have PI files that are executable, and what you do when you build the documentation is you actually run the code that runs the analysis and generates the figures, and then that gets kind of put into the HTML and the website, right? So every time the documentation is built, the examples are run, and that's a nice way of doing a certain type of continuous integration in the development stuff. So the notebooks aren't the source code anymore. The notebooks are generated by Python source code, so just text source code, that are a combination. They're kind of like the way that Sphinx works and Sphinx Gallery works is it's .rst, so it's like blocks of restructured text that are, I'll find an example of this. It's like blocks of restructured text inside a Python file. So it's kind of, it's sections of effectively a notebook that are broken up by comments, and in the comments or the commented lines, there's something that's basically more or less .rst, and that gets parsed from that into HTML, and the Markdown component of a Jupyter Notebook. Okay, so basically the Python source files, maybe I'll just kind of screen share while I'm just talking through this. If people are interested in hearing these things, I don't want to be too boring.
No. I mean, this is super important, and like you said, like want everybody to basically start from scratch. Download this and try this out with your own, with this a wide variety of hardware as possible. Yeah,
good. So I'll
and I've got a few follow-up questions that
I'll definitely take questions as well. But I'll continue what I'm saying, but I'll do it with a screen share so you can see my browser right now.
Yeah.
So there are a few things that I don't necessarily want to rush over, that I do want to make clear to the people who are interested. So what I was saying just now in terms of the structure, and this is how you see this generally with these type of Python libraries, is like M&E and Nylern and other libraries, Foof, which was the main one that I used. They all have this kind of generic structure where you've got your main library. In this case, it's called EGMB here, and then you have a folder that's examples, and so the examples folder, well, the ENGMB folder, this has the source code. So in here, we have stuff like, without going into too much detail right now, but this is quite a nice one actually, and this is really Jaden's work. So Jaden did a lot. Jaden, just in case people don't know, has been like the primary contributor to this project over the last few months, much more than me. So we now support multiple devices. I mean, say multiple. We support OpenBCI devices, and there's a capacity for supporting a lot more via BrainFlow, because Jaden figured out that BrainFlow support, and a lot of devices work with BrainFlow. So we've got this general abstracted device class that you can basically initialize with different device variations, and specifically, like you tell it your device, and then your device could be one of these BrainFlow supported devices like an OpenBCI Cyton, or it could be a Muse, either a Muse 2016 or a Muse 2. And depending on which one of those it is, there's some different stuff that goes on in the background. So we tried to kind of unify the API for quite different mechanisms in the back end that are initializing the data stream. So that's really cool, and it really works a dream for the OpenBCI devices. It actually is smoother and easier to use for OpenBCI than Muse, which is, cool. Yeah. So device more device agnostic. That's a big feature. Another thing, as I was saying, is the way that the source code is written for the examples. So your typical organization for these type of projects, as I said, you've got your kind of primary code folder, you got a folder called examples, and you got a folder called doc, which is the documentation. And the doc, when you're building the documentation, you're in the doc folder, but for some reason, people tend to separate the examples from the doc folder. And so here's an example of this is what's now replacing the notebooks, is these, I should say, just go back a sec, these Py files. I had to number them and give them a little prefix to get them to kind of present in the right order in the Sphinx gallery. The prefix actually means run it or don't run it in the build. So this one that's prefix X here, this one isn't executed in the documentation build, because this one is streaming a device and you can't run an EEG stream when you're trying to build HTML documentation. That's not the kind of thing that that's for. But this one is just doing the kind of middle chunk of what was done previously in the N170 notebook. So, but the new kind of version of the source is things like this. We've got, text and then code and then some text in a comment block and then some code and then some text in a comment block, etc. like so. And then that then becomes the thing that say this one here. This was the one I was showing you just now. So all of this text gets compiled at the documentation build into this, all right, kind of pretty web page. And at the bottom, and it's kind of important, is you can download either a Python source code or a notebook. So it's still EEG notebooks, right? There's still a notebook that does the stuff, but the notebook is now not the original source object. The notebook is constructed from a more manageable type of source object, which is, as people know, like Jupyter notebooks aren't good source code for, because they have binaries and they have like weird JSON structure and they don't diff properly. So that was something that I wanted to do to just make things make more sense from a development point of view in the repo, and it's working quite nicely, I would say, so far. One or two other new feature things. Well, actually, I'll just point to the API again, but I'll show you the API in the documentation. So this is what it looks like now. So if people remember what we had before in the, I won't show it here, but what we had before was you would manually run a bunch of sub-processes, a bunch of Python sub-processes in order to essentially initialize 3 separate things that need to be going on concurrently in order to stream your data, run your CyclePy experiment, and record the LSL output streams from both of those to a single file. So, and that was all done, by the user in a call in their Jupyter Notebook cell. So that's all going on in the back end now. You don't initialize the sub processes. That just happens basically here. So I'll just say what's going on here. So you're importing the device, as I just described, this device object, and we also have experiments. So now they're not. I mean, I could kind of abstract them. I don't have an abstract class structure for experiments yet, but it still kind of looks as it would do. You import the experiment that you want to do. The experiments are the same set, but they've been slightly renamed to make it obvious that this one is a visual. So this is a visual, faces, houses. Okay. So you just import, you initialize your device, you tell it what the file name is going to be. We've done a little bit of stuff trying to standardize the folder directory structure for that. And then this is the one, effectively the one-liner that runs your CyclePy experiment and records your EEG concurrently as well. So that's nice and tidy. So that's quite nice. And what you can also do as well is you can do this without giving it the EEG device, and that'll just give you the stimulus presentation. So, and you often need to do that. You often need to test when you're coming up with a new CyclePy experiment. You don't want to be having to stream your EEG all the time every time you want to change some of the parameters. So that's all cool. I have one other update thing to point you to, and then I'll field some questions if we have some questions. Is data. So as I said, the data in the previous version of the repo, we had a folder called data that had a large amount of data in. And we've moved over to a dataset fetcher model, again, more off the pattern of Nylearn and similar repositories. So essentially there's a permanent-ish cloud location, and we just pull it from that URL. So if you don't have the data on disk at this point in time, then there's a little helper function that checks that. And if you don't have it, then it grabs it. And that looks like this. So this web page here is an example of one of the examples that's actually executed at the documentation build stage, because it doesn't have it's not trying to do EEG streaming. So it's just using it's just using stuff that you don't. All of the stuff that's needed for it is there in the code and in files that are downloaded. So what the dataset fetcher looks like is this. So it's basically you just import this fetch datasets thing, and then here we go. So if this path doesn't exist yet, then so this function basically sees if actually what we could do, and actually what Nylon does is it kind of absorbs this if statement into this function. So it does the check itself inside the function. But either way, this is grabbing the data from currently it's from a Google Drive folder. They'll probably be switched over to OSF or some other more kind of standard, but it's fine in Google Drive. Like I don't really care. So the example data has been kind of moved out of the repo, and basically you download it as you need it, and you need it when you're running through the examples. So if you don't want to run through any examples, then you don't need the example data. And if you only want to run through this example, then you only need this example data set, and you don't need the other ones, etc. So it's a little bit more, finessed in that way. You just fetch a data set, and then the rest of this example is just straight out of the, let's say, classic M170 notebook that's been around for a while.
John, if I could butt in for a second, we have that the part where it checks if the path already exists. We have that in the dataset function.
Yeah, I was thinking that while I was saying that. Yeah. So actually, this line is kind of redundant, isn't it?
Yeah.
Yep. Okay. So good. We can take that out.
Awesome.
And yeah, so you can you should be able to, if you want to play around with this and this is all completely new to you, you should be able to, after you've done the installation. And when I was saying some of the things that we're still filling in is some of these documentation pages, but it should certainly be comprehensible, particularly to people who've seen this stuff before, but pretty much to people who haven't as well. You should be able to pretty quickly get to running this example and getting down to here, and that should just work because it's just loading data. And I said there's last thing, but I have another quick thing, which is I've also made a binder configuration for this.
Yeah, I saw that.
Yeah, right. So the badge is here. So that basically and tested it and it works. In fact, I tested it, and here it is in the browser. Okay. Actually, that's timed out now. But something I need to add in is the pulling the data set feature. But basically, this more or less to set up for binder, you just have to have a folder here that gives an environment, which is kind of like a readme.txt.
Yeah.
A requirements.txt, and you have this thing called a post build, which is like some bash commands for stuff you do after that. So actually I added in a post build that installs a library, and it downloads the Jupyter notebooks and unzips the Jupyter notebooks, so they're in the folder. Yeah, whatever. But the bottom line is, if you click on the binder button and you wait around about 5 minutes, then you'll get a in the cloud free Jupyter server running, and you can go ahead and do particularly all of the analysis stuff that I talked about. Obviously, you can't stream. I don't know a way of streaming to binder from your Muse on your head, but all the analysis things you can do in the cloud without even having to install.
Awesome.
Okay, that's enough for my monologue.
No, but that's awesome. So, well, sorry, Jaden, was there anything else you wanted to add to that?
Not really, other than I had in the BrainFlow notebooks repo originally, I had the support already in for the other BrainFlow devices, so I'm going to work on adding that again. But I don't have anything to test. I don't have those devices to test it on. So if there's other people in the group that can run the test with that, that'd be great. I did just pre-order the Notion though, so I'll have that I think they ship in 5 weeks, so I can at least test that one myself, because that's been added to BrainFlow recently.
But on testing, I mean, Notion support, really awesome. Yeah, looking forward to that.
So awesome, because I did talk to AJ.
Yeah.
And I was asking, I was asking about, if anybody would be interested in testing this out and stuff. And he was just like, yeah, well, there's this, I forget your Twitter. It's like NeuroClean.
Yeah.
Yeah. Anyway, so I was like, oh, okay. Well, and then he asked if there was BrainFlow support, and I was like, well, yeah, actually, NeuroClean.
Yeah.
So
independently known by multiple people, you're an influencer.
Well, it was funny because I've talked with him quite a bit on Twitter, but for so long I didn't have my name in my Twitter bio, and so he came and like talked on the Hack Night call here, and I had a conversation with him over video, and he had no idea who I was because I don't have my name on Twitter.
Yeah, sure. That's awesome. I've got a unicorn coming.
Oh,
so,
cool.
So I will be able to test that, and I also posted the new. I mean, it's the same URL, but I posted that on what is it, like Open Brain Talk. I mean, basically BrainFlow's Slack.
Okay.
And, so basically, one was telling Andre. Just because, like, Andre, I know, would really like to advertise that, EEG Notebooks is, supporting BrainFlow now. But
I focused hard on the Open BCI stuff for a while, just because of the competition thing we were working on with them. But now that that's all up and working, I can start putting everything else back in.
Yeah, I mean, and well, I don't know how many. Is it? I always get it wrong. It's like BrainBit, or is it BitBrain? Because there's two companies.
I think it's BrainBit. I think BitBrain is the one that's running that research thing.
Yeah. So, well, we should come back to that. Anyway, but I posted that on their Slack. Hopefully, hoping that somebody would be interested who's got hardware. Again, like getting more diverse hardware, trying out and just saying like, hey, if you want to try to collect ERPs with your equipment, like, we would love the feedback.
Yeah.
And yeah. So if I could ask a couple questions, because certainly in playing with it and kind of like starting from scratch and also just thinking about the documentation, I mean, are we expecting people to be using it like they're a developer, in the sense that, like, is everybody like pip installing it -E and like
my thoughts exactly.
Because I thought it was really cool that I got, so that's what I did do, obviously, but I thought it was cool that I get this EEG Notebooks, /data directory in my home directory. And I was thinking just about like NiLearn and M&E, like when M&E goes out and gets data, and not only M&E, but also, of course, Moab, because hopefully we'll talk a little bit about Moab too. I can go out and I can get data, and it pulls it to this other directory, so that it's not basically going into, the library that potentially end users aren't going to want they're not going to be working on the library. They'll have just conda installed it, or pip installed it, and what directory will they have, or like what will we be setting up for them?
Are you are you asking like where if they fetch the data set, where it'll save to?
Well, so like I know where the so the data gets saved, or at least on my Linux system, I'm getting an EEG Notebooks /data, and then
that's changed now.
Oh, sorry.
That's changed now. If you run it, since we did the shift over to master, it'll now actually save to your the home directory of the PC. So it's saved to like, for example, in my Windows, it saves to like c/users/jaden/.eegnb, and that's the main data directory now.
Yeah. No, that's what I'm doing, and what I'm saying is
that's what M&E does, and that's what Nylon does. That's what DiPi does for the example data. But I think you're asking whether the location of like new recorded data should be a different folder than the. I mean, that's totally up for discussion.
No, it wasn't so much. I mean, like, kind of like sample data and the data you're collecting could both be under EEG notebooks, but from your, that's at your root level. That's cool. Can I put experiments in there too? Instead of do I need to always load them into? Do I need to load them into the library? That's the bit that I'm wondering. Can I, now that we've got these paths like data-dir, can I use that to add experiments without adding them to the library? And are we just expecting that anybody who's adding experiments is basically hacking on the lib? And
I'm not exactly sure what you mean, like the folder for the data.
So I think what he's saying is that like
EEG and B/stimuli.
Sorry, John, you're getting like muted.
Oh.
Yeah, I think I saw John's lips moving, but I couldn't hear what he was saying.
I was just saying the top level folder directory. Is if that's not like obviously configurable, it should be, and it can be, and it should be. If that's what you're asking, but I'm not sure that is what you're asking.
I think what you're asking is that, so we have the set experiments now, but let's say you want to run an ERP experiment, not with like faces and houses. Remember you mentioned like faces and cars in one of our messages. So you want to be able to just like, point to a directory where you have these images located and then have it run the new experiment, right?
And basically what I was wondering was, are we shifting over so that you can pip install the lib, right? And it's got like pre-canned experiments, but that I could use like EEG notebooks in my home directory to like basically put in a folder called stimuli and put in a folder called experiments, and essentially have like user installed experiments and stimuli that I don't need access to the pip install or the site packages.
Yeah, we should definitely make that easy to do. And I mean, honestly, well, there's at least two versions of that, right? One is because the experiments are defined, they're Python files, and they have quite a lot of stuff in there that is not. It's quite kind of deep in terms of I mean, there's CyclePy, but there's also this other stuff to do, like initializing the EEG strip. The point is, you can imagine something that's just substituting the stimuli, for example, that you would want to kind of facilitate without having to go into, without necessarily having to kind of create a new, or get involved in the code for the experiment definitions. So that's one thing. And then another, and then maybe that will come in the form of a kind of abstract, an abstract experiment class. But broadly speaking, like the idea at the moment is every new experiment should have have a name, and it should have a folder, and then there can be variations on that experiment. So there's a folder that's Visual N170, and then I'm anticipating there being, as many as we care to add, like variants of N170, and that could be, variant that uses stimulus set 1, stimulus set 2. That might end up being the most natural way of, incorporating that kind of lowest level of experiment variation rather than trying to abstract it, which would, add more bloat and stuff like that. We won't want to do that yet, I don't think. So if you're just talking about like a slightly different N170, then the natural thing to do is to just go into the folder that is the N170 and they just make a new .py file that's got some slightly different whatever stimulus directory calls or something. Now, where does that sit? As in, does it, you know, as a kind of user specified one versus that isn't where the pip install? We're not necessarily supporting that at the moment, and that's a really nice idea. So there's a whole load of interesting questions about this kind of extensibility dimensions that we really haven't been thinking about at all yet.
Sure. Well, I mean, you know, so I'm asking because I, of course, had already started doing this, and you know, and to sort of bring it back to what I know some people are here for, which is core. You know, I took, you know, so Emily.
I still had questions. I've been waiting for like 2 minutes.
Oh, sorry, Ricky. I'm not.
Yeah, okay. We're still good and great, but how far away? I posted in the chat something called Voila, which is even on Jupyter.org. So maybe, so it looks like it's supported. Can we just, all this Python stuff is cool for people that want to start designing their own experiments and at their university and, you know, using this as a building point, and it's great to have that open source for everybody to build off on in the coming years. But can we just have an app and it just dumps the file in the documents folder? You just Jaden got it pretty close, but I still had to install all the Python dependencies. So how far away are we from just building all of this Jupyter Notebook as a standalone app? You run it and it dumps the files in a folder.
Yeah, we want to do that for sure.
Yeah,
because I can do this, but I'm also kind of I'm a developer, and other people just aren't, or they're just starting out as a developer. And then there's people like in junior high and high school, and they want to be whiz kids, and they're trying to be a developer and do BCI starting out at the same time, and they need a lot of support. And you know, if they can get the electrodes connected to their head properly, they're doing great.
But so, you know, what we've got for the competition is close to this, right? It's a one-liner that's running an experiment, and I think, as you were saying, the thing that's not quite streamlined as you'd like is the installation steps.
Yeah, I mean,
yeah, that's pretty much it. And you just need, if there's a way to self-package it, maybe this. Do you think this Voila thing can work, Jaden?
So where I see it running into an issue is when we try to do it on Windows, because we need to simultaneously run the BlueMuse backend. And so I think honestly we would have a better chance of not using Voila, but using like I think it's called PyInstaller, and it creates a .exe of it. But I would have to create some type of like kind of like the input interface where it asks you what device you're using. And I also have to put a spot where it specifically tells you if you're using Muse to like start up BlueMuse and wait for that to account for it, which is I could do it. It's just going to take some extra work, because that's kind of the main issue, is that once you run the single installer for everything, you have to build it for all the different platforms and account for every different device someone's using.
Yeah, that's the hard part that Jaden has really been trying to accommodate, and I think has really brought the repo into the next level. And so even going back to when John was sharing his screen and showing the folders, maybe there's a folder missing that's going to be called builds, and y'all could maybe start making releases.
Yeah, I can start tackling that the figuring out on Windows how to deal with the Muse problem, and then that'll basically solve everything. Because I've worked with PyInstaller before, and it works really, really well for creating, like, as long as you just build it on the operating system that you're building it for, it works really well with creating a pretty usable exe.
So, long story short, for everybody else, is it on the road? Like, are we going to get there eventually?
Eventually. I would say it's definitely not one of the probably like top 3 things on my agenda on this. But if John thinks that it should be, then I can move it up.
I think the primary agenda at the moment really is everything that's needed. Well, okay, the number one thing in the agenda is the documentation. There's gaps in the documentation, and other things that are around kind of finessing the workflow and also kind of filling out instructions on the workflow around just where are you putting things? What are you running? Where does the data go? There's more things we can do on kind of facilitating the loading and stuff. So there are a lot of things. There's a kind of laundry list of things that are more or less just tweaking things that we already have with it before we start kind of adding in major new things. I really like the idea, though. I think
it'd be
very much like within what we're trying to do, right? Which is, you saw the tagline I have in the repo, it's like democratizing the neuroscience experiment, which I like that a lot. I want to kind of propagate that meme. Really, like a natural endpoint of that is to remove all of the hurdles of all the technical hurdles, for sure.
Yeah, I've worked with I can't remember the name of it now. One of the kind of like basic Python GUI creators, and so I could actually try to do something like that again, and just create like a front end GUI where instead of creating these little like prompts for each person or for each individual thing, just have like different menus to select from. And then that'll also, give you the prompt to, or I can even make it maybe link to where Blue Muse would start and actually run it, start it from there as well some way.
Well, that sounds cool. As long as y'all could get the documentation squared away, like John's saying, is the priority. And then maybe just whenever y'all are ready and y'all agree, say, hey, let's package it up and let's put it in a box and put the bow on it for everybody. And do that. And if you focus on that at the right time, maybe it'll all come together.
Like one of the things that is, on the agenda, and one of the reasons why we're working together is we need more data. We need more recordings from more people in more contexts. And what you're describing could be actually a mechanism to give that a boost. I mean, initially I was thinking well, actually, I want to focus more on getting more recordings and getting more people contributing more recordings. But it's possible that actually the best way of doing that is packaging it up a little bit more, and then that would allow people to do that. Then there's a question of what is our mechanism for people contributing, which we nearly have sorted, right?
Yeah, we can talk about that. Me and John participated in a meeting with IEEE Dataport, and I, as a developer, they had their lead developer for the Dataport on the call, and the man walked us through everything. He from the onset of the meeting, he said, if you have feedback, we may be able to make changes to the system. So he was open to feedback on how to improve it even before sharing. And that's really cool. Great attitude. And there weren't many suggestions we had. It was great. Really cool stuff. So to handle all of the data for all these people that want to run EEG notebooks and they want to submit their data from all over the world, diverse communities, diverse people, how do we store this data? And well, there's all different types of places. I'm not going to go over through it. But let's say Amazon S3, and we have this Neurotech Challenge website, and it's WordPress. And I was like, okay, at the very least, people can make a WordPress site, and they can submit a form, and we hide that form for only people that are signed in. Dataport already takes care of that. And I'm sure they already have a mechanism to weed out bots trying to make users and things like that. So it looks like we might just make a competition data set there. People make an account with IEEE Dataport, and they upload their data, and we can collect that, and it won't be shown who. This is another thing we asked. It can't show people's names, right, Morgan? Not really fair to show that Richard W. Uploaded a file at Tuesday at 8 o'clock in the morning. It's a little too much information for anybody.
Well, yeah.
And so we can just collect that data in one phase And then I think we were saying maybe make another competition that, by their own words, it's still one competition with multiple phases for us, but for them it's 2 separate competitions, and that would be for analysis to people to submit, you know, their deep learning models or however it works. Anything you want to add to that, John?
No, that's good. I mean, yeah, the nice thing is they have the S3 stuff, like, looks like it's figured out, and they have a good front end, and they have some you know, professional people on the job. So it's great people to be working with for facilitating this kind of data community data contribution project that we're going to be running.
And we asked if we want to convert it to supposedly a free open access data set. There's a conversion tool even. They already have that. Might just stay as a competition and you can access the data in the future. Maybe. We'll see. But yeah, I'm very impressed. I'm no longer worried about how we're going to collect everybody's data securely. They're doing Amazon S3 in the background. The thing, you know, John, the thing I forgot to ask in the meeting was, do we have programmatic access to those S3 buckets? Or is it just we're told using S3 and we never are allowed to interact with them? Because that maintains security on their end, and they have to really think it through if they're going to allow people with programmatic access. Like Twitter, I think they just released an API, and they took forever or something. For a good reason. We're probably abusing the old one or something.
Yeah, we should look into this. I mean, I can imagine multiple solutions, right? Then just, we don't need their console, but maybe they can grant permissions, SSH access, or anything like that.
And
yeah,
and Jaden and Morgan, and there can only be one owner of the competition. So we're going to talk about that tomorrow, I guess. I guess it might be Joe or somebody. And it's easy enough for anybody to manage, really. Just a bunch of checkboxes and forms. And plus, it's very official once you make that competition and it gets posted on their website. It's like, whoa, we're ready to publish. We've got this going on. Here's the deal. Here's the terms. Here's the ethics. You know, real official stuff.
Yeah,
Cool.
I sent Alex a data port link, or that here, let me just I thought that was, you know, that popped up today in just this IEEE email, just eye tracking data. But anyway, no, this is great, and you know, I'm super excited. So I have been a little. I mean, I haven't been getting everything to work as it did before with Linux, and I am trying to work out what that is, and I'll open any issues that relate to the things I'm finding. The other thing that I you know, and this was super useful for me, just in terms of learning the new layout, was like trying to, you know, like putting together my own experiment and you know, seeing what would need to be added and what paths I would need to have, and or, you know, what variables, you know, variable names I would need to create to have paths, and which files I would need to put those in, right? And also being, sorry,
I'm going to guess what you've been doing. Have you been taking the ERP core stimuli and making an experiment from them?
You guessed it.
Yeah.
Wait, can you say that clearer?
So I've basically been taking the the N170 and the mismatch negativity, or and at least the auditory presentation, and trying to adapt those to match the ERP core resource from UC Davis and San Diego State. So Emily Kupperman sent me the stimuli that they use. So the addition
is the N170. Is that the flashing bars?
No, it's not the steady state VEP. Is different.
N170s are faces houses.
Yeah.
Oh, okay.
And well, in this case, in their case, it's faces cars, and so there's a couple different things that now I've gone through both experiments. So one, they use
sorry, but like faces houses would be FFA versus PH. PA parahippocampal place area versus fusiform face area.
Yeah.
Canwish 1990s functional brain imaging.
And
do you want to elaborate on that in case that's completely like nonsense to people, Morgan?
No, that's awesome. And the brain robot, what is it?
So 70, it's faces. It's the response. Is that right or wrong?
Yeah.
It's a face selective response. So what I was talking about just then, sorry to interrupt, Morgan, but like what I was talking about just then is, so in the kind of visual neuroscience field, there are kind of things that people are interested in terms of visual processing and kind of processing functions that are contrasted against each other, if you like. And one of them is what's sometimes you can think of as like objects versus scenes, right? So maybe a glass on the table versus looking at a country sunset or something, right? So that's a very different type of visual information. And one of them is, and there are different visual processing pathways for figuring out the location and the identity of something that's close to you, and you can kind of articulate a movement on versus something that's more seen and contextual like. And faces are more in the object category, and scenes are obviously in the place category, right? So you have versions of these experiments that are about. I mean, it's actually the idea behind faces versus it's houses though, isn't it? Is it houses or is it scenes? I guess it's houses. Okay. So houses are like kind of visually they share some some configurational features to faces, but they're not faces. And that would be the same idea with cars as well.
Yeah. I mean, it's the CBMM. It's the Brains, Minds, Machines summer course right now, and Nancy Canwisher's, or at least one of her talks is one of the first YouTube videos that you'll find. And anyway, you can see in the different faces and other objects experiments this very reliable effect, right? And but I do notice a couple things just in terms of like the stimuli that Barachant added was from the Pi MVPA, and I forget that it was like basically from, I think from like a 2001 paper from Dartmouth, right? Which makes sense that those guys would, include that. It's the Pi MVPA people being from Dartmouth. But there's a couple things about the stimuli, like the current N170 is grayscale, and these are color. And then they've got a white box. So basically, it's still it's the same area with the same kind of like cutout of the face and things like that. But there is this like white box. And the nice thing being that what this data set or this image set, stimuli set includes is a scrambled version. So you get, this is taking that same image and making that image have certain visual properties matching and certain visual properties, but obviously it's no longer a face and it's no longer a car. And
is it more akin to noise?
It's like,
is it squares?
Visual property matched. So it's like hopefully like how much you're getting from like the intensities is matched, but is definitely like it's not an object. Like it's sorry, I can show you an example just so you can see what that looks like. Let me just see where I've got these.
About the notebooks, there was, I guess it was the SSVEP one. It showed my whole screen and it had like a lot of flashing lights. It might have been a seizure warning.
It might be good to include a seizure warning, yeah. But that's kind of the point.
And so, and it definitely, so I would like to
SSVEP?
I'm sorry, what was that?
Which one was a whole screen of something flashing?
That's the SSVEP. So it's supposed to flash at different frequencies and then elicit that same frequency in the occipital lobe.
And what's the third experiment?
The P300, the anticipatory response.
And what does that look like? I forget.
That'll be cats and dogs.
Oh, really? Okay.
Which I've been meaning to. Where does that stimulus come from?
What?
So, here, just 1 second, and I'll tell you.
Maybe Oasis.
They all come from Alexandra Barchon, I think.
But there's a file. There's a file that describes. Just 1 sec.
It describes why
a blog post from a while ago that has some,
Well, at least in the N170s, he included a license file.
Yeah.
And
so
let's check.
The P300, I have a question I wonder about in particular because I noticed in the code it specifies that the cats are the targets and the dogs are the non-target. It's supposed to be anticipatory, and so it kind of assumes that you're a cat person, no?
Yeah, we've talked about this. We're working on doing experiments too, but using the external trigger to time lock. And we're gonna. From talking with some of our advisors and really smart people that we have on board, that we needed to do the full image set from Oasis to get the full range of emotional response, and that's going to include a disclaimer for like adult images and things that are disturbing. Making sure people agree to that. Because put cats and dogs for emotions, which is different from you're just looking for identification, right?
So
valence and arousal.
Right, we're not looking at that. We're just looking. It's just another ERP that's supposed to be.
Yeah, but for valence and arousal, the puppies and kittens are they're like the same thing. People are going to think they're cute, and so that's sure enough. But maybe we might. But what we talked about in a meeting on Tuesday was that maybe we can do both and try to do the puppies and kittens for identification. And I guess they need to base that off of the EEG notebooks, really.
But it's not identifying specifically puppies or kittens. It's just you're supposed to be anticipating, and someone can correct me if I'm wrong with this, but you're supposed to be anticipating seeing something, presumably cats, and then when you see it, it elicits your the P300, right?
Yeah. So you're given I haven't actually run this one, so I not quite sure what the instructions would be, but P300 is typically you get some target stimulus, say an X, and some non-target stimulus, say an O. And every time there is an X, you press a button or you count, or you're supposed to be attentive for the target.
Physically press a button also.
So it could be physically press a button. It could be just count them, and you'll be asked at the end, like, how many X's appeared, and so I'm just reading the license file. All the files in this directory were downloaded from Pixabay and are public domain. So
right.
There's so in this particular case, I think they're just playing with the idea of the P300, which is it really could be anything, right? You could have it be like this, pictures of dogs and pictures of cats, and usually the main thing is that the target is in the P300 is usually less frequent. And so you're also kind of setting it up with the basically you're setting it up with the frequency, and there will be other designs that either try to switch the target so that again, like an X and an O has slightly different properties, right? Because like if you're fixating, then the X is kind of where you're fixating. The X will show up where you're fixating, and the O will be blank where you're fixating. And so people would talk about like, well, maybe you're getting like more light. So
that was exactly what I was thinking about, because they were saying with the cats and dogs, maybe it would be. But it's like some pictures of like there's one picture of a cat. It's a nice cat, but it's like dark and it's like. It's like shadow effect, and then others are nice and bright. And is the color palette of it influencing our brain?
Yeah.
Rather than looking at.
So these weren't pulled from a real experiment, right? And so this is what you'll see with the stimuli, the N170 stimuli for ERP core. You'll see that anyway, like you can do a much better job of matching these things in terms of their properties, and some people will take this to to quite an extreme. But the main thing being that like it's not the picture response. Like you kind of want to remove the picture response, and it's really about the cognitive response of you're seeing a target, and yeah. So
Morgan, do you think we should use ERP core for the Open BCI challenge?
So I would love to, and so my like first kind of like real technical question is just is a 10-minute session too long?
Oh, he's gonna say no.
And I don't,
Oh, you mean like
one
a
10-minute
session? Oh.
So in ERP core they split it up into two blocks, and they give people a break. That makes it more annoying to work out the randomization, which I was trying to keep as just a one-liner in terms of can I draw from these? So in this case, it's there's 40 images in each of these 4 conditions. So so it's car faces, car scrambled, faces scrambled. And so it's the only thing left is just making the draw correct, which, as like sometimes takes like, sometimes the most code you have is just for doing the trial presentation order.
Do they do a random draw? Or do they have a fixed order?
They don't have a fixed order, but they do have like some constraints. Like every every image, I think it's like every image is presented twice and no image is presented twice in the same block. And you know, because they've got these 2 blocks. So I was like, well, can I just make it 1 block? Makes it a little easier. Anyway, but the images are great. You get the scrambled version, which is super cool. And you know, and it really it's just down to this last little piece of logic in terms of getting that order right. And then, you know, the awesome thing being that you not only you have this a better kind of like visual psychophysics version of the task, and at the same time, like this is a task that works pretty well with these electrodes down here. You know, it's not perfect, but it's not an SSVEP, so. You know, I think it's
this is great. I'm really glad to hear that you've been doing this. I hope that you can get it working very soon. So I would definitely be behind using this as a you know, as the thing we use in the competition and the kind of front, you know, one of the main things in the thing. But we need to do some recordings.
So
did you say it takes like a car and that is the X and then the O is just the scrambled version?
Oh, so we're talking about 2 different experiments. The P300 is the target non-target experiment. Okay. And I'll give you the ERP core version of that in just a minute. Because there is an ERP core version of that too. And it's again, like all the ERP core experiments are designed to run well in 10 minutes. So, I mean, the good thing being is that they were definitely trying to have short runs, you know, which I think is helpful.
What's the ERP core software? Is it MATLAB?
So all their stuff is in presentation.
Oh yeah, right, yeah.
You know, that neurobehavioral system stuff. Anyway, we can, I mean, I can run it with a free version, but I will thank again, Emily, for just sending me the images and not having to actually dust off a Windows system and break open those EXEs. But let me just show you the anyway. I got it working, so it's like, you know, I drop in the four folders. You know, I even created a license file that just says this is from, you know, a 2011 paper. It's a French-Belgian group. I forget the 2 authors, but they listed in the ERP core paper that's on SciArchive. And so we've got a paper we can draw on for this, and we get the scrambled version, which is cool, right? And so, you know, I just had to add a link in the stimuli. I forget, it's like stimuli utils, or let me just see what anyway, I had to add in the path for that directory, or where you would find those directories. And so
stimuli should probably be a download thing at some point as well.
Is it big?
Well, just in general, I mean, it's going to be images, right? And we want to be like supporting a lot of experiments. And
I mean, this is why I was asking, like, under EEG notebooks at your you know, home directory, could we just have stimuli? And because if I'm creating this path, I could just as easily not give it a path to the you know, site packages.
I would consider switching it over to expecting stimuli to be in a home folder or something like that.
I mean, I was kind of,
because it would. I think it makes more sense to think, well, but then you've got your okay. on one hand, it makes sense to think of stimuli in the same way you think of data, but on the other hand, the stimuli are kind of coupled to the experiment things, which are, you know, Pi scripts in the experiments folder.
Yeah.
So you could go one way or the other.
Yeah. I mean,
design choice. Yeah.
You know, it's the only other modification was you know, basically it's a 4-class presentation as opposed to a 2-class, and so, and at least in terms of, you know, I don't think I've got the randomization correct. Like,
is that because it's got scrambled as well? Is that...
It's got scrambled. Yeah, it's got scrambled of both versions, right? And so anyway, I mean, I've got a 1-line, you know, NP random. I mean, it's like NP choice, and you do this 4 draw, and basically it gives me, you know, 1/4 of each, you know, in an array. So I get these values of 0 to 4. I mean, 0 to 3, and you know, and then I can choose from the right directory. But I'm still not quite, you know, still not quite sure I've got the matching randomization ordering of herb core. But it works in the sense that, like, it finds it. I just don't understand why now my the regular N170 is not working. Or at least the problem that I described today. Is like, if I don't use again, this is partly Linux related, right? Is that I still need to do, you know, the IPython notebook, like, you know, list muses, and making sure that I'm getting the, like, Linux muses.
That should all be done inside the.
I see it. I see it in EEG. You know, and yeah, if I don't do the IPython notebook, then I don't get it doesn't pick up. I mean, if I don't follow the old IPython notebook, not the process stuff, but the here, let me just, because you still got the Linux directories, or, you know, the, sorry, is it under note? Yeah, so under notebooks, it's like I still need to take the SSV. I mean, I basically took the SSVEP underscore Linux notebook and modified that to work with am I doing this right? You see, this is how I'm getting it to work currently.
Are you screen sharing?
I was just, I mean, let me, sorry, I can do it again. Oh no, I still, yeah, I'm still, it's definitely working if I start the stream process. But I know that if I just took, you know, the snippet from today in Slack and just replace the board name with Muse 2016, like, you know, I'd turn it on before I'm running that, and it would just still be spinning, still be, you know, waiting to connect.
Okay. Well, let's try and follow up.
I'll but the cool thing is that like with some needed tweaks, the stimulus presentation with the new stimuli is working.
Yeah, that's awesome. That's definitely a better thing to have as the go-to.
Yeah,
more psychophysically kind of verified, more kosher.
Yeah, and
ERP science thing.
And I think we just need to like add a particular global variable so that we can have a quit. It would be.
I don't know. Yeah, for PsychoPy, yeah, I know. I mean,
like escape should escape. And I think we just
try double clicking with your mouse. That kind of.
You cannot get out of a PsychoPy experiment if it doesn't want you to.
No, it's a mess.
I've had to hard reboot.
Yeah.
What? Oh, that bad? Okay.
Yeah. like opening up Task Manager, nothing will work.
And anyway,
right?
I know we can add that. I mean, it's something that we just need to add into the PsychoPy script.
Is that because it's hijacking the display driver?
I think so.
I mean, yeah.
That's like the number one thing that caught. I mean, blue screens, I don't know. They still happen in this world. But for me, they happen a lot less. And I'll tell you one thing that'll send my Windows system off the rails is I have like multiple monitors, and then one of them switches from one computer to another when I turn it off. And then I'm streaming audio out of my driver, and it just says no. It doesn't want to add another monitor. Oh, it was if I was playing a certain game, and the game I don't know. Yeah, that's how I figured that much. But Morgan, you're talking about using just the paradigm from ERP to improve the existing experiments.
From ERP core, yes.
Yeah.
So this is this is a very high profile ERP lab that that is giving you 6 reference experiments plus 40 subjects of data collected with those 6 reference experiments.
Oh my God! And we could just multiply that, hopefully.
Well, and so this totally seamlessly segues into our other discussion topic of the evening. And let me just get the.
If 40 subjects can make such a huge paper, be interesting to see what 1,000 can do.
So yeah. So this is what I've been super interested to work with other people if they're interested. This is 40 subjects of data. The particular paper that's being worked up on this data set is really focused on collecting having this open science data set, and with these particular paradigms it's showing you like how they got their particular grand average ERPs. And when I say that, like, I'm using like their vocabulary the way it's been used historically, which is we're talking about one channel which shows the greatest difference, and potentially and somewhat how these particular experiments get their names in things like the N170 is kind of like a window of like 150 milliseconds to 200 milliseconds post stimuli. That these very narrow but you know, again, historically, this is how ERP research has been done, right? At the same time, there's these 40 data sets where we've got multiple experiments in the same subjects, and you've got 30 channel EEG connected to the biosemi system, and they've given you the raw data. And I think it's really interesting, you know, and, you know, so this is what I've been talking about on Slack, where some, you know, interested students are asking about like good places to start. And, you know, I really want to push ERP Core partly because it is this, you know, it's a completely open resource, which, you know, definitely meshes with NeurotechX's mission. But it just turns out that this is exactly what, you know, Steve Luck and et al. Want to see happen with this, in the sense that, like, not only that, but so the webinar that was scheduled for August 12th got postponed. It got postponed to August 26th. But if
the ERP Core focused webinar,
yeah. So
I probably should attend that.
Yeah. So let me just drop in a few links. So,
I mean, if I'm on this road of learning about how to do experiments for EEG, it seems like the wheel's already started and I'm on it.
Yeah, and so let me, you know, you know, so, and then let me take it one step further, which is, I mean, I've dropped in their particular, I mean, their website is erpinfo.org. Then off of there, you can see their blog post about the resources for teaching. And then the last link is a link to the course that the virtual ERP bootcamp. So like EEG Lab, they run an annual bootcamp. So it's usually a week, and you know, people actually go there in person and do this either in Davis or San Diego. And but I think, like everybody, they've looked at the, you know, the post-COVID world, and they said, hey, we gotta, you know, it's virtualize or die. And they've put together you know, even more resources to make this virtual. It's kind of you know, a MOOC now, and even as far as like some of the discussions that we've had about Neurotech EDU, NeurotechX EDU 2.0. I love this. This is part of this Pursue a collaborative initiative, which is preparing undergraduates for research in STEM-related fields using electrophysiology, which is something that we've certainly talked about, you know, as what we were kind of like hoping with a NeurotechX EDU, you know, 2.0, right? And so,
where's the info on the video, the thing that got postponed? So I signed up for the virtual ERP bootcamp.
Yeah, so go to erpinfo.org.
Okay.
And then the second link is the webinar for August 26th. You know, the webinar got postponed to August 26th. And you can sign up.
All right.
And next week, he's also doing another webinar, and it's like teaching psychophysiology. I forget, in a pandemic or something like that. or online or you know.
So should I do the boot camp before this, or is it like should I just wait?
Yeah, I would recommend
introduce me to the boot camp.
Yeah, I would recommend, if you can, doing the virtual boot camp, just because it's a great intro. You know, it's a really.
It says this should take 6 to 10 hours for you to complete this course, just for everybody else.
It's a low impact intro. You know.
Sweet. I guess I'll maybe try to knock it out in 2 days. We'll see.
And again, like you've got people you can talk to about it if you've got any questions. And yeah, so separately, and this is you know, this is what you know, with Divesh and Rakesh, if he's interested, and anybody else, you know, we've got the 40 subjects of data too, right? Download. And so we've got, and as part of this, they make available their MATLAB scripts so that you can go from the raw data through pre-processing, through ICA, you know, detection, correction, and additional, you know, segmentation, QC, averaging, grand averaging, to get to basically the figures in their paper, right? What I think is really interesting about that is that at least getting up to, say, right before averaging, you know, once and you're in EEG lab, you can also get some really interesting additional views of the same data, right? So where historically people have averaged, right, looking in a single subject at, you know, say the you know, reaction time sorted trials in an ERP image, or looking at some of the, you know, sorting the single trials, you know, looking in the, you know, choosing the channel that they're using for the grand average, and then looking in a single subject and seeing the trials sorted by, you know, pre-stimulus alpha or something like that. You can take a really interesting, you know, wander through the history of you know, cognitive neuroscience in terms of, you know, what's happened after ERPs and other views of the same data, right? Because again, like 40 subjects is not bad for an EEG study. Sorry, my dog is making noises. Anyway, for those that are, so if you're interested, I mean, there's a couple things that I'd like to do. One is just showing people with a Conda install of M&E Lab how you can view this data right now, and you don't need MATLAB. And you know, again, I can't say enough about, I mean, you know, it's like we definitely want to get people using M&E, but you know, an intro to M&E, or you know, a gateway into, you know, full M&E is M&E Lab, right? And certainly one of the biggest problems that you have with, you know, like Alex mentioned early on, you know, biggest problem you have with EEG data sets, especially that you're getting raw, is blanks and eye movements, and especially if those electrodes are close to the eyes, like, you know, like Muse being right, having two right here on the forehead. M&E Lab is designed as an EEG lab replacement, or a Python version of EEG Lab, in that it gives you the similar GUI with file open, etc. Similar attaching electrode positions and things like that to the files, but a viewer and producing power spectrum and things like that. But most importantly is giving you a visualization, a very easy to use visualizer for doing ICA component removal, right? So it's producing an ICA decomposition, and you can choose an Infomax, or you can choose their Picard. They want to say is faster version. I haven't actually had great Picard results, but I was rooting for the Star Trek connection, but mainly being like ICA component identification, at least the way it's been done is still visual. And so one of the things I wanted to talk about was a project with so how to make this a non-manual process, right? And certainly, so if you're not familiar with it, labeling.ucsd.edu is that actually right? Or maybe you still need the SCCN. Yeah. So this is another great, or both a good resource and a good learning tool. And this isn't an EEG thing, in the sense that, like, if you use ICA to process your, say, resting state fMRI data, you're going to have this same problem, in that ICA is a technique that you can use like PCA, and you can order by variance explained, but that doesn't necessarily tell you what are signal and what are noise components. So once we get the ERP core data, it's really great to see the amount of detail that the ERP bootcamp people have given us, in terms of shifting events and all these like super important corrections, really. But things that we don't really talk about a lot in terms of data processing, and you get to see a very detail oriented ERP lab go through a complete pipeline. But this ICA step, I'd be really interested to hear other people's opinion, if you have any, in terms of how we can automate this particular stage. Because it's one of those things, just like with any machine learning, where you've got to have labeled results to be able to machine learn a tool that will do something here, right? So certainly what IC label is trying to do is get more labeled data. And that is actually the basis of FSL's fMRI tool that tries to automate independent component analysis, ICA component identification, called Fix, and it's a separate download because it comes with a whole lot of training data. So it's like almost a 2 gig download, and involves a bunch of additional R packages, and I think is doing some random forest classification given your data plus the oh, okay. And let me just see something that's be up there. And you're talking about BOSS. Oh, what did I do?
Yeah, I was just wondering if that could be maybe something of interest, because it's a one-time shot, but it's like you kind of curate it to some degree. It's a really interesting article. I was actually on a journal review session tonight with a gentleman who actually presented that. So I don't know if it's of interest, but maybe sort of find out, because if you're really worried about the biggest concern is not having enough label data, you can start with the label data, curate it, and then actually run it through this algorithm. He has everything else there. He was using obviously for image processing, but there was a lot of talk around being able to use it for something else, anything else, NLP, structured data, or any other sort of signal processing. Anyway, it's just seemed like it might be relevant, so I'll throw it out there.
Yeah, I mean, so one of the things. I mean, I can tell you what people have definitely tried to do in the past, and that is, you need a viewer, right? So this is why I super recommend M&E Lab as your first viewer, and ERPCore as your first data set, where you can see real data, and you can go through. And just like we saw with the Neureka challenge, epilepsy challenge, you can go through and start identifying eye blinks in your subject's data, right? So doing hand event marking is actually something that has been, like widely done.
Amazon sells it as a service. They'll label, you just feed them the data and you say, hey, can you label this with this thing for me? And they'll quote you. I don't know how much they'll quote you, but you can pay for it and they'll do it.
So, sorry.
Is that through Mechanical Turk, or is that through an algorithm?
No, they can have humans label your data. And so I looked into it a while back. I was like, okay, I guess because you asked them to hire a medical professional to label EEG data for seizures. And I'm sure AWS could find a way, maybe.
Well, yes, I do believe in Amazon's ability to do that. But if you don't have that, I mean, this is only going to be semi-useful for the data that we're collecting. Partly, so this data set is 30 channel EEG, and what I would love to start with is just how many kind of like events per subject do we need to hand label, such that then you could have have the ability to then learn from that subject what blinks are, and again, like we can't be the first ones trying to do this in M&E. So I know
the software solution be like real-time annotation software.
Well, let me just.
I mean, the way it used to be was you've got a neurologist right there on the paper, and they just write their annotations right on the paper.
Sure, and that's kind of what I'm talking about in terms of like that is what people would do with blinks, and then what people would do. I mean, this certainly what we would do.
The patient rolled over, I guess.
Well,
maybe the tech does that.
So you'll see this in later steps of ERP pipeline is usually after some filtering and things like that. You know, this is kind of before ICA, but usually, you know, you'd have some filtering and then you segment on your events, right? So the events in the, say the N170 is you're putting up the pictures, right? You know, so it's cars, faces, scrambled cars, scrambled faces. But you're taking like 200 milliseconds before and a second after something. And then there would be lots of software, including EGIs, that would then give you a really fast viewer such that you can step through, you know, just clicking a button, you step through and you see each trial. And then you basically go good or bad, right? And you're mostly just looking for whether the person blinked during that trial. And you know, now historically, again, like you would just reject those trials. And as long as like you'd set some sort of threshold for like, well, you know, as long as I'm not rejecting like 50% of my data or something like that, then I'll keep that subject. And it's usually down to, you know, some power analysis that you've done of how many ERPs do you need to get a, you know, how many trials do you need to get a good ERP? And you'll see, you know, again, like the ERP core paper, the SciArchive paper has this kind of discussion in terms of, you know, how many trials did they end up rejecting and how many subjects did they end up rejecting? Yeah. So this is cool. So yeah, I'm hoping to, so for those who didn't see it, Divyesh has put in a link, and so I'm really hoping we can get this Mohit Agarwal at Georgia Tech to actually come talk to us. He's got another project called Cerebro, which I just think is a cool name. This is, yeah, and you'll see, I've got a link. Mohit's got the...
this must already be on the citation list, hopefully.
Yeah, so Mohit's active in the Open BCI forum. And he's got, and you'll see, I put in a link in the meetup agenda. So in 5 minutes, we're going to talk about Mohit's list of EEG data sets. Because, yeah, I'm wondering right now if he doesn't have like an even better list than the Short Center. But yeah, I mean, so I like this. I mean, I like this. Certainly what we used to do was add blinks into an experiment. So like before, you know, experiment, and you'll see this in PsychoPy experiments, right? Is in like the PsychoPy tutorials. So there'd be like the training session that you do with the subject first before the full experiment begins. So basically you do a mini version to get them to understand the experiment before they go into the real thing. And all we would add something where you just say like blank, blank, blank. you know, and then maybe put up, you know, 4 quadrants and then say like, you know, find the dot and to create eye movements. And then you just use that as your training data, right? I mean, blinks are big enough that once you get like,
it'd be great to confirm the blink also with a camera too. I don't know.
Yeah, but it's like, honestly, the blinks are they're so much bigger than endogenous brain activity that it really doesn't take much. And you just want to see what the kind of like the profile of them is across the electrodes as they got attached to the head. And yeah, it really doesn't take that many to get a good template, but I do like this. And again, like, yeah, anyway, I for those that are interested, we're, you know, I'm hoping that some UC Davis people will also be interested. But yeah, even if it's just a core group of a couple of us, we're going through the EEG lab and ERP lab scripts and producing an M&E version. And yeah, so the only other thing that I definitely wanted to talk about this evening was adding, so I don't know if people saw in Slack that Maria Virginia asked about in the Moab channel about doing a comparison of some particular, well, mostly like PCA related techniques. So there's like minimum energy, canonical correlation analysis, and common spatial patterns. And whether she could use that, I mean, whether Moab would be a good framework to look at differences between those techniques. And you know, and it was great to you know, Sylvain chimed in, a couple of people chimed in about what's, you know, I mean, certainly like that's exactly what Moab is good for. I'm also, you know, I've talked about this before, like Moab is also really a great framework for doing what Steve Luck and et al. Are doing with ERP-Core now, in terms of if they don't do ERP analysis, they're doing decoding. And all that, you know, this decoding, all the decoding paradigm is saying is like, let's not treat it as an averaging problem. Let's treat it as a classification problem. And with one additional caveat, which is that they care about when in time you're seeing differences. and Moab is not historically, or at least in the comparisons that I've seen, is like a classification of the entire trial. But in terms of, you know, what Moab, well, so just wanted to kind of go over again, like what Moab is doing. And of course that, you know, so it's got its data download features, in the sense that like, if you don't have data, installing Moab and running its, you know, running its like kind of like main all is a great way to get a bunch of data sets downloaded to your home directory. And, you know, so we talked a little bit about the data download features in EEG Notebook, and it's doing exactly this, right? I'd love to see ERP-Core be added to you know, like herb core would be super easy for us to add. It's all prepared for us. What is the next part of Moab is that if you're benchmarking something, if you're benchmarking particular analysis pipelines, it's always better to benchmark against multiple data sets, you know, and see. So, you know, basically not overtrain on a particular data set, but look at multiple, say, motor imagery data sets that are at least trying to get similar phenomena, but say they're using different channel counts, you know, different kind of like quality systems, different numbers of channels, and potentially different variants of the task. And then certainly some of those variants include much more multi-class versions of the task, and some are, you know, super simple binary. So currently, you know, and Moab started as you know, this BC, you know, mother of all BCI benchmarks, right? And that was when, you know, it was definitely kind of focused on can you imagine moving something and picking that up and doing it for them, right? And so those are what most of the data sets that are included right now. I see a kind of a big discrepancy between, like, if I follow the Moab instructions for, you know, what it says, Moab's version of kind of like quick start and run all data sets. I don't get all the data sets that are listed as like the data sets that are, you know, kind of like supported by Moab. And yeah, so there's already a discrepancy in terms of like the number of data sets I get. Right now, it says that there's a steady state VEP. If it's just one data set, that doesn't really help. But in the Slack, an engineer from Interaxon posted a couple awesome links to his master's work, but in addition, pointed us at some extra steady state VEP data sets. And yeah, so I mean, I think that there are enough steady state VEP data sets and P300 data sets that we could add to Moab to give it, you know, basically some new categories, right? So I don't know what we want to say is kind of like enough data sets to make it, you know, a real Moab, but let's say like 4 or 5 is at least, you know, a good number to call it a, you know, a generalized benchmark. So I just wanted to see if anybody else had more. So I posted a link to Mohit's EEG datasets GitHub repository. It looked to me like that. I mean, I saw a bunch of datasets I hadn't seen before. And it looks to me like it's something that he's created since the Schwartz Center's list of data sets that historically had been quite the resource. Let me just pull. Well, sorry, I've been talking quite a while. Anybody got any questions or?
Just go to the.
Yeah, I have a question. We just opened up a poll internally at BCI about what hardware we should use if we were going to do an emotion detection experiment. And from my understanding, from talking with John and Jaden on the EEG notebook stuff, is that having a different electrode setup just almost makes it a completely different data set. Like the headband goes around the sides, but the ultra cortex and the electrode cap can't go across the whole head with stuff in the middle.
Yeah. I mean, I would say, you know, one, can you make the reference the same?
It's the earlobes, probably.
So, you know, certainly a big there are things that you can do if you've got different channel configurations. Having a common reference point between them does certainly help.
It would be the earlobes with the ear clip electrodes.
Yeah, I mean, I'm just afraid of the linked ears, but
really,
I
think one goes into the bias and the other the rep. I don't know, something like that. But for emotion, are you also looking at stuff on the top of the head?
Well, I mean, you know,
it's very complicated.
It's you know, having like, there's certain things that if you didn't have the top, like, you probably wouldn't be, you know, it's like if you were specifically looking for like error related negativity or something, like that would kind of suck to miss the top. Emotion, I don't know, you know, like emotion is not so much, it's not so much like you're missing.
Right, I should say valence and arousal, because that's what Oasis does.
Okay. Yeah. So I'm not 100% sure, but you know, I think what you're getting the it's not just what the electrodes are close to. Having additional coverage allows you to kind of like do more source localization, or get it deeper sources by using the array. And
yeah, I know that'd be more realistic if we were doing 32 or 64.
Yeah. But
Jaden had asked me about electrode placements, and I think I updated some tables on our docs. So Jaden, you weren't expecting anybody to do 8 electrodes with a headband, were you? Or was it for the ganglion?
No, I wasn't expecting one to do 8 electrodes for the headband.
Yeah, did you do the ganglion with the headband? I think it's just the front FP1 and FP2, and then O1 and O2. Yeah. Okay, that's what I kind of echoed internally. I said, you know, ganglion works best with the headband. If you're using this little Velcro strip around your head, it's a lot of wires. That's one of the things the headset makes easy. It just manages the wires and puts the device on your head. And I've never actually used an electrode cap before. I don't know how well it would work with my thick hair. Hey, John, have you ever worked with a high-density system?
Yeah, I have. I used to do EEG and MEG concurrent stuff when I was doing my PhD, and we're getting a new high density system in Toronto. Actually, we're gonna get a biosemi. So it's been a bit of a while actually since I actually ran an experiment with a high density, but I definitely have worked with those things before, and the traditional devices anyway, like it's a fair bit of setup time. You're looking like half an hour plus of like dabbing goo into each of your electrodes, into each of your channels, and making sure that you get a green light on the impedance monitor, and the person sat there watching David Attenborough movies or something, relaxing. We're getting a biosemi active 2 system, which is a kind of semi-dry and active electrodes. I mean, they're semi-dries, and this was like quick apply wet electrodes, but they're active. So the idea is that they're a little bit easier
to. Are they spiky-ish, or
no.
There's none of that because you're putting gel.
Yeah, no, they're just flat kind of disc ones. I haven't actually seen them up close yet. I'll let you know when we get them.
Yeah, they're
But
flat.
I appreciate high density data. I mean, you know, I'm a neuroimaging guy, you know, so I want to see brain. I want to see brains. Ultimately, I don't want to see EEG topographies. Yeah. I want to see colored, pretty pictures in a brain with, you know, activity lighting up at certain times. So I have a natural inclination towards high density EEG, but I also really am into, you know, the things you can do outside of the lab with, you know, consumer grade devices as well.
So am I just old school, or is there a better way to produce the meshes for MEG data than MNEC? Is there any like in MNE, should I be able to generate, you know, inner and outer skull?
Yeah, you mean the BEMS?
Yeah.
There's MNE functions that call free surfer functions, right?
Yeah. Yeah.
No, I think that's the way you do it.
I mean, I found I'm processing some MEG and I re-downloaded MNEC, which I see has not been updated since 2016. But I know
and that does meshing.
That does. I mean, it does what you can do with BetSurf in the sense that, like, it'll take a T1 and it'll use this watershed to produce an outer skull. You know, I don't have 2 flashes. I don't have, you know, in the old school MNEC, it would be like collect 2 flashes, these, you know, different parameters, and, you know, feed it into this particular algorithm, and you'd get out the meshes you need, and blah blah blah. This is the T1 workaround. But there's got to be a better way, and I do have a T2 for this, so I know I can use, you know, BetSurf, but then I still need to convert it into, you know, not. I mean, it's basically like a .try file.
Well, I'm pretty sure there's an MNE function that is like generate services or something. You point it to a free surfer directory, and it runs a bunch of commands, some of which are free surfer commands.
Yeah,
I generate the BEM stuff.
Yeah, I think I'm just gonna ask on the list because I'm like. But I swear, like, you still need to download MNEC. Like it's got some free server functions, but it's like things like M&E setup, source space, like don't exist in the free server 7.1.1. Sorry, they're getting. Anyway, I just feel like M&E Python just kind of expects you to either have that already done for you some other way, or for basically to use a one sphere head model.
No, I think it just expects a recon all folder, and then it'll expect access to free surfer binaries, and then it'll generate the meshes that it needs from that if you don't have them ready. I think. Okay.
Because I gotta say, they're the most recent M&E documentation on it is like, it's like, do you have your subject stir set? Which is is basically assuming that you've already done it all, and there's some other
Well, no, as soon as you've done recon all, and then it does some extra things on top of recon all.
And that's the bit that I just don't think that they've got the binaries in there without M&EC.
Okay.
I mean, again, so sorry. It's
Shop talk.
It's been a long time.
Shop talk.
I mean, 2016, like it hasn't been updated.
Actually, I was looking at the SPM website for some reason, and the last SPM release was 2014. Yeah,
well, they're always like, I mean, we're 2000. SPM 8 was like the version to use until at least 2016 or.
Yeah, well, 2014, right?
Yeah. Well, okay. Yeah.
I don't know if they're planning on ever releasing a new SPM. Like maybe SPM's just kind of done. I don't know. But it's been nearly 10 years since the last major. Well over 5 years since the last major release.
It's moving.
Did you say Free Surface 7?
7.1.1.
Free Surface on 7. I don't pay attention.
Well, it's because then you'd have to rerun everything with stuff.
Yeah, right.
If you wanted it
on every operating system.
Yeah, if you wanted it to be that was the funniest thing about Gail's comments and the container discussion at OHBM. It's like if you get different results running on different platforms, then I don't believe your optimization. Yeah. I just really quick, I was just going to show the what cars and cars scrambled look like. So
if we were to get the color palette of how many red pixels, or I mean, it's not just red, there's shades of red even on all of those cars.
Yep.
But you would have the same number of pixels per color. Is that right?
Right. In terms of the scramble. Yeah. And so it's not that these faces are, equal. It's that I'm going to present each face twice.
It's great that they all fit within the image themselves too. Like the center of each face is almost the same for each face.
Yeah, and then so these are the scrambled faces, and and again, like it's this particular 2011 paper that they are getting this paradigm from was a great low level vision science group, right? So they're doing this well, and there's lots to like. I mean, for those that are interested, please run through the virtual ERP boot camp, and I'm going to run through it too. And, very happy to answer, if you've got any questions, let me know. Cause I mean, I'm again, like trying to see this looks like a great resource, and then
I take you up on that if you're ready to play professor.
Yeah. And then, like turning more of their 6 experiments into CyclePy experiments that we can use.
I'd just be happy to understand each one.
Yeah. Well, so we can start with that. Certainly, back in the day, I was doing, I started with these N400 like syntax violation paradigms, and event-related negativity was a big focus of Don Tucker and Fawn Liu's research work at University of Oregon, which was, we were in the research, electrical geodesics was the research park of UVO. So I've seen a lot of ERN presentations over the years, and then the P300 experiment that they are doing is a multi-class. It's letters, but it's like A, B, C, D, E, and let's say that E is the target, but you're seeing, so they're doing all of those letters, and I forget if you're pressing a button. But it's a nice design, and I think they're getting from the I forget if they're getting the lateralized readiness potential. So one of the experiments, you're definitely pressing a button because there's a lateralized readiness potential. And there's a visual search. It's like 2PC or something. That I can't, but we'll cover those, the mismatch negativity, and potentially the P300 would be super easy to add. Putting up letters shouldn't be too hard, and it's just working out the multi-class randomization trial randomization, right? That I'm still working on, but we're coming up with 5 minutes. Anybody, especially any newcomers, have questions or topics that we can follow up on with you? I'm sorry we didn't get to more ERP core analysis, but again, like not offline, but online, very happy to set up, separate focused meetings on just going through the ERP core processing scripts, and, focusing on like what M&E tools potentially can be used to automate anything that is non-automated in the current scripts.
Yeah, I'd be interested in that if you're doing it.
Yeah. So do you mind if we stick? I mean, I think on Slack you'd originally asked about auditory experiments in particular.
Yeah.
Does so would you want to play with the mismatch negativity?
I am not familiar with that.
Oh, so it would be like classically it's sometimes just called like a beep boop, in that you got like two tones that one's presented less frequently than the other, and you get this very early signal difference off of the less frequent tone. That so it's one of these things where it's just like you typically, I think in this experiment, so typically you give the person another task to do. So it's maybe that they're watching a movie or reading a newspaper. I've seen reading a newspaper. And so it wouldn't be getting exactly at your attentional kind of like focus that kind of comes out more with like the P300 or the it's like the N2PC, or I forget what there's another, it's like a visual search that I think is definitely attentional related. But I still think that there's a lot to learn from just seeing the pipeline steps. So
okay.
Morgan, something that's occurring to me with this that you maybe want to do, maybe you don't, is I'm wondering whether any of the PsychoPy people would be interested in OpCore, right? I haven't had any interaction with them, but you know, I know it's a big community, and I know there's like solid developers and so on.
Yeah.
And I feel like it would be good for us to start kind of talking to them.
Yeah.
And maybe a you know, what'd you say, seal of approval, proper cognitive neuroscience experiment corpus like OpCore is the right thing to bring them in through.
I think that's an awesome idea, and you know, it popped up in my head because I saw that, you know, like I think it was this week or maybe last week, but like PsychoPy 2020.2 was just released, and when I started, you know, I got a one-line Numpy like you know, call that gives me a string, you know, gives me an array with my, you know, values 0 to 3, right? But I still don't think I've got the proper constraints on it. And I was honestly thinking about like going back and doing a PsychoPy tutorial. But yeah, I could ask on the forums. I mean, I definitely would like that. And
they could help out with the implementation, but they might be interested in the tool, and they might just generally be good to talk to.
Yeah, as well as like, I mean, what I wanted to kind of say, and you know, I'll learn. I did download Presentation, the free version of Presentation, so that I can run these on a Windows PC and see exactly what it is, right? And then I can ask on the forum, and you know, happy to send Jonathan an email and just say like, are there experiments that, you know, are already being used, you know, as good intro experiments that are close to these, you know, that would be good to modify. Because yeah, I mean, like Steve Luck is already, I mean, they've both said that they would love to see PsychoPy versions of this. I'm hoping that they would also like to see M&E pipelines if they're, but that's not important. Like they're making it available so people can do what they want with it, and they're making it all freely available under Creative Commons. They're like, you know, do your own trainings and teaching with this. So. And again,
this sounds like a good thing to put out into the Twitterverse, doesn't it?
I've been
Try that way.
You know,
Yeah.
At least as Neurotech SF. You know, so when we're going to cover this, I've been including. I think it's ERP Bootcamp at ERP Bootcamp.
Oh, right. So you've already tweeted at them about
I've tweeted and I've talked to Emily and Steve.
Right. Okay.
So they're and they've been super responsive and super helpful.
So maybe we should do an at bootcamp at PsychoPie. Let's get together.
Yeah. I like this next stage, and yeah, I think, you know, I mean,
21st century science. Let's tweet people to form a collaboration.
Yeah.
How can we strategize our Twitter comms? Jeez.
Yeah, it's a good it's a good idea, and again, like, it's a great data set, like, that hasn't been looked at in some, you know, some kind of like or certainly, you know, I'm looking at how easy it would be to get, you know, kind of like classic McKeague ERP images and things of the same data, right? And like, that'll be interesting to look at. Wearing a she's wearing a wig. So let me wrap up for yeah, I mean, tomorrow Allen Institute's again is doing their final day. There was also great there was a great physics talk. Is it Ben? You know these people at Sydney, Ben Felcher?
Yeah.
Yeah.
Awesome. You're talking about the HTSA?
It was like U Sydney Physics did an event last night. Well, it was their afternoon.
Oh, right. I didn't know that.
Yeah. So I'd love to pull out the references, but if you check his U Sydney page, his 2019 papers, all super interesting, and they had basically, you know, 3 neurophysics talks that were awesome, and who else? And then there was great NeurotechX and Brain Products and Ant all did, you know, really interesting webinars that you can find. I think I've posted these all in Slack. What are you looking forward to next week, John? What's coming up?
I'm looking forward to having a fairly clear schedule for the first time in about 3 months.
Okay.
That's where I'm at the moment. I did last week. I was teaching a SciNet course, which is like the U of T supercomputing kind of grid facility thing. So I was doing some more. But the what do you say? The workshop conference visual summer school summer slog has concluded for me last week. So
okay,
I'm looking forward to not thinking about schedules of exciting things. I know that's really boring.
No. It's totally understandable. Yeah. It does remind me, next week, for anybody who can catch the time zone, NeurotechX Berlin is having their inaugural online meetup. If you can join, do to catch those folks in Berlin. So one of which.
Do you know who? Yeah. So do you know who that's centered around and what they do?
Please check Slack. It's like NeuroFox, then a guy at like medical AI at Charité, and a third person. And okay, I'll be right there. Okay. Yeah, so that's coming up. Check Slack for more postings. But Berlin will be fun to catch, and I know there's something starting next week that I'm not remembering. Let me just very quickly check my. Oh yeah, I've got innovation in brain-computer interfaces also on the 18th. Is that so? I know that University of Melbourne is also, or people mostly in Melbourne are putting together a NeurotechX Australia-like group. I don't think they're formally NeurotechX, but anyway, check that on Eventbrite. Some really good people there as well. Yeah, and I would like, just like with Foof, I'd love us to be getting, more linked in with Dave Lively's kind of modeling. Which, I mean, I think of as like